Okay, we're going to go over a couple examples on how to expand these logarithms. Okay, so we are starting out with one single logarithm, and we are going to expand this to multiple different logarithms. Okay, when you guys go about expanding these, the first thing you should do is you should always split up division first. I always want to split up my division. So if I look up here, I've got 2 square roots of x divided by x minus 3. Okay, so I need to expand those two. Now, when I do this expansion, I'm going to have now 2 logarithms instead of just 1. Okay, one of those is going to be a log base 2 of 2 square roots of x. The other one is going to be a log base 2 of x minus 3. And since I'm dealing with division, when I split these up, that means that in between those 2 logarithms, I should have a minus sign. So my first step is to split up the division. I've got a log base 2 of 2 square roots of x, which is my part on top. I've also got a log base 2 of x minus 3, which was on the bottom. And since these 2 numbers were being divided by each other, that means that I need to have a minus sign in between them. Okay? So that's our first step, splitting it up with division. The next thing that I need to do is I need to look for any multiplication going on. So here I have an x minus 3. Some people might be like, oh, I should split that up and I can use division. No. You can only split up division. If it's subtraction, you're done. There's nothing else you can do to simplify that, unless there's an exponent and you could move that exponent out in front. But that would be the only one. Okay? So if I'm looking for multiplication now, I've got a 2 here, and that 2 is being taken times a square root of x. So those 2 could now be split up. And since they're being split up with multiplication, since they're multiplied together, we should be splitting them up with addition. So I've got a log base 2 of 2 plus a log base 2 of square root of x. So my 2 and my square root of x, those split up, and they split up with an addition sign because they were being multiplied together. Okay? Now, once I do that, I need to check and see if there's anything that I can simplify. Oh, whoa, my gosh, I'm sorry. I also forgot this minus log base 2 of x minus 3 is still there too. Sorry about that. Almost forgot to write that. Okay. Now that I'm done with that, I need to look if there's anything that I can simplify. So the first thing I notice is on this first one, I've got a log base 2 of 2. Remember, that's a 2 to the first power. Those 2 bases match. So those things cancel, and I'm left with just a 1. Another trick that you need to be prepared for is dealing with this square root here. Because we know how to write square roots as exponents. If we remember back to our jam rule, we can write them as fractions in our exponents. So if I'm dealing with a square root, even though it doesn't write it, that means that there's a 2 out here. My a is just an x, and that x is to the first power. So my m is a 1 and my j is a 2. So square root is to the 1/2 power. So this square root of x, I can rewrite that as x to the 1/2 power. Okay? So I look to simplify. I did that here. I'm also looking for any exponents, because if we remember our third rule that we went over, says that if I have something to some power, I can move that exponent down and out in front. Okay? So I'm going to take this 1/2, and I'm going to move this 1/2 out in front. So I end up with a 1 plus 1/2 times the log base 2 of x minus the log base 2 of x minus 3. And I'm done with this one. That's my answer. Okay? When I'm checking for my answer, I just want to make sure, is there anything multiplied in here? No. Nothing multiplied in here. Nothing divided in here. Nothing divided in here. And then I'm looking for any exponents. No exponents. Technically, there's a 1. You could move the 1 out in front, but 1 times anything is just itself, so we're not going to worry about that. We had the 1/2 here. We already moved that out in front, so we're taken care of there. Okay? So my kind of steps that I do when I deal with these is number 1, deal with division. Number 2, I deal with my multiplication. And then number 3, I deal with exponents. And that also kind of includes our simplification, if I need to simplify anything. Okay? So those are kind of my steps that I do to try to solve these problems. All right. Then, one more. Okay? And this one's going to have a little trick to it. So we're going to start off with division. So I've got 3 divided by that bottom x times x minus 2 squared. So since I'm dealing with division, I'm going to split that up. It's a log base 2 of 3 minus a log base 2 of x times x minus 2 squared. Okay? So my 3 was on top. This was down on the bottom. Okay? Hopefully you guys remember division means that we're splitting them up with our subtraction sign there. Okay? Now I'm going to look for anything that is being multiplied. Okay? Well, I see an x here. And I see an x minus 2 squared here. So since those are being multiplied, they are going to be split up using addition. So I'm going to have a log base 2 of x and a log base 2 of x minus 2 squared. We split those up. They're being multiplied. Split them up using our addition. Okay? However, this whole logarithm that we just split up has a negative out in front, which means that that negative has to go to everything that we just split up. Okay? Still have my log base 2 of 3 out here. But this minus log base 2 of this, we split up that log, that negative is still sitting here out in front. So when I go to try and simplify this, this negative not only goes to this log, but it has to go to our next log as well. We really have a log base 2 of 3 minus a log base 2 of x minus a log base 2 of x minus 2 squared. Okay, so you cannot forget. And this will occur anytime there's multiplication on the bottom of a fraction. Anytime there's multiplication on the bottom of a fraction, you're going to have to deal with this distributive property. Okay? So, all good there. Now I'm just looking to simplify and for exponents. Can I simplify this? No, their bases don't match. No exponent with this, we're good. This one does have an exponent here, so I'm going to need to grab that 2 and pull that 2 out in front. It ends up giving me a log base 2 of 3 minus a log base 2 of x minus 2 log base 2 of x minus 2. Okay, remember you definitely need to have parentheses around that x minus 2 because there are 2 terms there. We don't need our parentheses here or here because there's only 1 term inside there. But those are 2 examples of expanding logarithmic expressions.